So you guys are going to be able to find the derivative of more complex functions using the rules that we talked about today. Okay? In your homework, you're only able to do about maybe half of it because we didn't get through the full lesson. Okay? So once we go over the rest of the rules today, you'll be able to finish up the homework and have it ready by Tuesday. All right? So the first rule deals with e to the x. If you have the function e to the x, the derivative of that is just e to the x. Okay? It is just e to the x. And if you have ln of x, then the derivative is 1 over.
So if it's 2 ln of x, it would be 2 over x.
Exactly. And the same thing applies with, it was like 3e to the x, then the derivative would be 3e to the x. Okay? Now the next two, product rule and quotient rule. Okay? Product rule is used if you cannot recognize that you are basically multiplying two functions together. That could be x minus 2 and then like 3x squared plus 12x plus 16 or something like that. Okay, like you have two functions that are being multiplied together. Then the derivative of that function is what's here. Okay, u of x basically represents the original first function, and then you're going to multiply it by the derivative of the second function plus the original second function times the derivative of the first function. That is product rule. Okay? The more we do these, you'll notice me, I'll probably shorten them and I'll say first times the derivative of the second plus the second times the derivative of the first. Okay? That is product rule. Now quotient rule, it's called quotient because you basically are dividing two functions with each other. Okay, so your original function is like one function divided by another function. Then the derivative of that is the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Okay? Now when I learned derivatives when I was in high school, my teacher taught me low d high minus high d low all over low low. And it stuck with me forever. Okay? Low meaning the bottom one, the one that's down low. D high, derivative of the high. Minus high, function on top. D low, derivative of the bottom. All over low low. Okay? Bottom squared, low times low.
Okay.
We're going to practice.
Wait.
All right, so we're going to find the derivative of these three functions. First one, 3e to the x. The next one, x squared plus ln of x. And then the last one, ln of e to the 3x. And find the derivative of all three of those functions. So, the very first one, 3e to the x is nothing but a constant times e to the x. What's the derivative of e to the x? E to the x. So this is just 3e to the x. Not going up. This one, you use your sum rule. Take the derivative of both pieces. What's the derivative of x squared?
2x.
2x. And what's the derivative of ln of x?
1 over x.
And there you go. There's your derivative for that one. Now see. Who remembers from exponential logarithmic unit?
Oh, I did this last night. They cancel out.
What cancels out?
The E and the L.
Yes, ln and e, they cancel each other out, which means that your exponent is going to drop down. So this is really just f of x equals 3x. What's the derivative of 3x?
3.
There you go. So don't forget about your rules as well when it comes to the exponential ones. Yes? times your times e to the x. And remember, just with applying the constant rule, the constant multiple rule, you basically are taking the derivative of the function and then multiplying it by 3. The constant on the front. So the same thing with like 3x squared. Like you bring down your exponent, you multiply those two together. So you take the derivative of this and then multiply by the constant that's attached to it. And the derivative of e to the x is just e to the x. So it's the same thing. And when you start adding in other variables and things like that with the 3, then it becomes a little more involved. That's there. Give you guys a second to write those down. Alright, so if you look at the first two, a and b, you basically have two functions that are being multiplied together for both of them, and for c and d, you have two functions that are being divided. So the top two, we're going to use product rule, so we're going to use quotient rule. So, to find the derivative of this first function, recognizing there's two functions being multiplied together, you can use your product rule, which says the first function. So you'll write 3x plus 1 times the derivative of the second function. What's the derivative of ln of x? 1 over x. Plus the second function, which is ln of x, times the derivative of the first function, which is 3x plus 1. What's the derivative of 3x plus 1? 3. Okay? Once you apply the rule, it's just simplifying after that. Okay? So you actually want to multiply 3x plus 1 over 1 over x, and you want to multiply ln of x and 3. Okay? So when you multiply the first two together, what's 3x times 1 over x? Which is? When you multiply?
3x plus 1 all over x.
Okay?
So it's 3 plus 1 over
When you do
x.
the first one, you multiply it. It's just
I thought you guys were going to simplify it, but
And it's 3 plus 1 over x.
that's what I was trying to get to. Alright, and then what's 3 times ln of x?
3L.
Yeah, so this, I was hoping that someone would say 3 plus 1 over x was 3 ln of x. That would be your derivative. Alright, let's look at B. So we're going to use product rule.
And it wouldn't work the same way if you foiled it.
If you actually would. If you actually multiply these two together to get the full polynomial expanded, and then you took the derivative, it would be the same answer you would get if you did product rule. Okay? It really would be. Alright? But just depending on what type of problems you have, I mean, if this is a trinomial times a trinomial, you know, it might get a little bit involved. And then you're dealing with the time issue. So you take the first function, which is x to the 4th plus 3x to the 3rd plus 6. You multiply by the derivative of the second. What's the derivative of this?
2.
2. So a nice little distribution. Plus the second function times the derivative of the first. What's the derivative of the first function?
4x.
4x cubed plus 9x squared. And it is simplifying from there. Okay? Distribute over the 2. That's 2x to the 4th plus 6x cubed plus 12. Foil this. 8x to the 4th. 18x to the 3rd. Minus 4x to the 3rd. Minus 9x squared.
That's what it is.
And then combine like terms. So you have 10x to the 4th. 6 minus 4 is 2 plus 20x to the 3rd. Minus 9x squared plus 12. Yes? And there's your derivative. It's the same thing you would get if you were to actually expand that first, multiplying at the top, and then taking the derivative of that polynomial. Depending on how fast you are, it could be about the same amount of time. You have another option. Okay. Questions on product rule?
That's as far as you take it.
No, you don't try to factor it. No. All right, here we go. Quotient rule time. Okay. The derivative. Low. D high. Derivative of the top. What's the derivative of the top? 5. Minus, and this is so key. This next part is where students tend to make some mistakes. Minus high. D low. What's the derivative of the bottom? 2x. A lot of students forget that they have to carry this negative to this entire second part. You're subtracting this whole part right here. Okay? So do not forget that. All over low. Yep. Now with quotient rule, I would personally suggest leaving the bottom in this particular format. Okay? And the reason why I say that is because however the top simplifies, it could possibly cancel out. Like if you simplify the top and the top can be factored, there's a possibility that one of the top factors can cancel with the bottom. And the only way that you'll know that is if you leave it in this particular form. Does that make sense? Okay. So now let's simplify this sum. When I distribute, I get 5x squared plus 5. When I multiply the next ones, I get a 10x squared plus 6x. But I'm going to distribute the negative. So it's going to be a negative 10x squared minus 6x. Everyone okay? That I did that in one step? So combine some like terms. And there's your derivative. The rule starts out how? Low, D high. Derivative of the top is? 1. That's always nice. Minus high, D low. What's the derivative of the bottom? All over. Let's simplify. Like once you apply the rule, everything else after that is just about simplifying. So be cautious. I can simplify this down some because I have a 2e to the x minus a 4e to the x, which will give me what?
2e.
Positive negative. Negative 2e to the x. The order in which you write it really doesn't matter as long as you have the negatives with the correct terms, then you're good to go. That'll be your final answer. You can't go any further than that. 2 more, and then you do some on your own. So let's have a look. We talked about this notation before. What's this notation mean? What does that mean? another way to do derivative. Yes, d over dx basically means derivative, just like dy over dx, just like y prime, f prime of x, etc., etc. So I need to find the derivative of this function. What are we going to have to use? Product rule. So bless you.
Thank you.
Product rule says what?
The first one.
First,
Times the derivative of
which is
7.
then
Plus second.
second function. And what's the derivative of my first? So you apply the rule, you've done the derivative. And let me tell you something. A lot of times, when I look at these mark schemes for, like, when you're doing derivatives of more complex functions, you know, they're like award a point if they recognize that's product rule, and then award a point if they get the correct derivatives. So, like, you find the derivative of 7x minus 2 to be 7, you know, you can get a point for that. And then finding the derivative of ln of x, you get a point for that. Okay? So, you know, showing the step, even though I don't know how you go from skipping this step to the final answer, I don't know. Someone's going to do it. So I'm just, you know, saying, you know, get the point just in case you make a mistake somewhere. Now let's simplify this. The first part would be what?
7 ln x.
Very good. And then
7 plus or minus 2 over x.
awesome. Now the next part. It says if a equals pi r squared, find dA over dr, and then this notation here. This notation basically just means to find the derivative and then evaluate when r equals 3. That's all that means. Okay? So, find the derivative and then evaluate when your variable equals 3. So, let's find the derivative of this function. Now this right here, what's this look like? Pi r squared. Area of a circle. When you take the derivative of the area of a circle, what do you get? You get circumference, right? Power rule says to bring it down to the front. Pi is nothing but a constant. Subtract 1 from your exponent. Yes. The derivative of the area is circumference. So now we're going to evaluate when r equals 3. So we just plug that in, and our final answer is 6 pi. I just wanted to do that. It works the same way with, what is it? Volume of a sphere. When you take the derivative of that, you get surface area of a sphere. Second. Question? What you guys try these for? Try these for. They mix just some practice with the new rules, but then also practice with the concept we talked about last class, which is writing equations, okay? But this time we're doing a more complex function. So I'll give you what? 15 minutes? And we'll see where we're at after that. You guys can work together. All right, so for the first one, you had to find the derivative. You should have gotten 5e to the x for the first part. Ln and e, they cancel out, leaving you with a 4x. The derivative of 4x is 4. Raise your hand, you got that one. Good stuff. Okay, hands down. Now it says write the equation of the line normal to the curve. So this is mixing in more complex equations and then writing equations of lines. What do we know about the slope of the normal line?
Opposite.
Opposite reciprocal to the tangent line. So we got to find the slope of the tangent line. And then also, we don't have our full coordinates to write our line. We have an x value, but how do we find the y value? Plug it into the original. Hopefully you notice that e raised to the ln is just x. So when you go to plug in 2, that's 4 times 2 is 8. 7? Yeah. So when you take the derivative, you get 4x plus 1. So when you actually find the slope, you get 9. So then your equation would be y minus 7 equals 9x minus 2.
Amazing one thing.
Thank you, because it is the normal. Got that? I figured y'all correct me, so hey, good job. All right. C. This one. Write an equation for the tangent lines to the graph of that function that's parallel to this line. Parallel lines have what types of slopes?
Same.
The same. So you actually have to figure out what is the slope of this one line. Get in the slope intercept form, and you figure out that the slope is what? -1/2. So you actually have to set the slope equal to the derivative to figure out what your points are so that you can write your equations. So derivative of that function means you have to use what rule? Quotient. And I'm going to swing down here to do this, and I'll split with that one. So I'm going to have low d high, which is minus high d low, which is all over low low. So then this is nothing but x minus 1 minus x plus 1.
Because it's x plus 1 up at the top. Because you did x minus 1 times 1.
X plus, okay, and high d low. Yeah, you're right. Okay. I'm about to say like this shouldn't be happening this way. So our x's cancel out, but our top turns into a -2 over x minus 1 squared, yes? So then we set that equal to a -1/2. Again, the only reason why we're doing this is because we're trying to figure out what our points are so that we can write our equation. A little bit of cross multiplying. 4. When I take the square root, I get plus or minus 2. So I'm going to get 2x values after I add 1 with a 3 and -1. Yes? Good stuff. So I got to plug both of these in to get our y values. When x is 3, y is 2. And when x is -1, y is 0. So yes, I am going to have two lines that are going to be parallel to the tangent line. And I get y, what's my slope? I can figure that out. So I got y minus 2 equals -1/2, x minus 3, yes? And then the last one is y equals -1/2, x plus 1. Questions? Yay. All right. Last one. What rule?
Product.
Product. First. Times the derivative of the second, which is 2x. Plus the second times the derivative of the first, which is what?
6x squared plus 2x.
Simplify.
Can you just go ahead and combine like terms into one step? For the sake of the word.
Yes. Yes. Very much so. So the derivative for this function should have been, after combining like terms, 10x to the 4 plus 4x cubed minus 3x squared minus 2x minus 1. Questions on using product rule or quotient rule or writing equations of lines with using these rules. Yes, sir.
Still going through part C, trying to find out how you got two different equations.
When you need two different points. Okay, so when you took the derivative of that original function, you ended up with that low squared, bottom squared. So then that way, after you simplified and you set it equal to your slope, you still had that x minus 1 squared. So you got your quadratic. And you never forget, whenever you take, the way I did it, I took the square root method, and it's always going to be plus or minus the other side. So that's where our 2 points are coming from.
So, because like what I had done is once you got it to x minus 1 minus x minus 1, I had canceled out one of the x minus 1s in the bottom became an x minus 1, and I thought we were supposed to do that if we had the opportunity to cancel out the.
Right, but you can't cancel it out because it's not factored out.
I'm about to say, yeah, because it sounds like you had an x minus 1 at the top. and it was actually an x plus 1 at the top. Like when you actually distributed your x's and canceling out at the top. So that might be where that error happened. Higher order derivatives. There are such things as higher order derivatives. When we get to the application part of derivatives, we like the higher order actually, represents something. But for right now, of course, you have your first derivative, which is, f prime of x dy dx. But then you have your second derivative, which, as you can tell by the number of prime increase, so f double prime of x, and then d squared y over dx squared. You have your third derivative, which goes with that one. So basically, the higher up you go, the increase of your primes. Once you get past 4, which you really don't see, they'll represent it with a number once you get past 4. So then once you find the fifth derivative, it would be f5 of x.
And so does that mean we just derive it again?
And then you just derive it again, yes. There's no way to go straight from your original function to like your fourth derivative without having gone through the first, the second, the third, the fourth. Like you have to go through each one in order to get to the one that you're looking for.
So you derive it once and you derive it again, correct?
Yep. And you take whatever you got when you derived it the first time, derive that to get the second one. Then take the second one to get the third one. You never go back to the original and like rederive. That makes sense. All right. So I want you guys to find the first 3 derivatives of this function, okay? I know you know how to find the first derivative, so go ahead and do that. But then to find the second one, you take the first derivative and do the derivative again. Find the first 3 derivatives. So your first derivative, you should have no issues finding that. Apply your power rule. So you get what? Plus 6x plus 1. Good stuff. So then your second derivative comes from your first. When you bring the 3 down, 3 times 4 is? So I have a 12x squared plus 6. And then I do it again. You have the third derivative, which is? Okay, so you just keep going. Yes, if there's a more basic one, which means that, yes, you might have to do quotient rule twice. Okay? There are those types of problems. All right? Give these a go. So that bottom one, I'm curious to see if anybody can get that bottom one. So you have to find the second derivative, which means you got to find the first derivative here. What was the first derivative? The first one? Oh, I already gave it to us, sorry. The second derivative then would be what?
2x.
2x. Sorry, I didn't see that. Yes, that was the first derivative already given to us, so we have to find the second derivative from that. Here we're given the original, and we're looking for the what derivative? Which one? We're looking for the third, okay? Which means that we have to find the first one. And we'll come back to this one after on Tuesday because I realized that some of you guys probably did it wrong because you actually need chain rule for this one. I didn't even recognize it, so I do apologize.
For which one?
B. We'll come back to that one on Tuesday, so I do apologize. But you good to see? What is the first derivative of this?
32t plus 16.
Negative 32t?
Yes.
Plus 16, so then the second derivative would be
Negative 32.
negative 32. Good stuff. So again, like I said, B will come back for the when we do chain rule. And now the first 4 derivatives of this function. dy dx. The first derivative would have been what?
Negative 1 over
Negative 1 over x
x squared.
squared. Okay? Remember, you can write this as x to the negative 1 and do the derivative of that. Okay? Before you make the exponent positive, you can just use that notation to find the other ones. What was the second derivative?
Positive 2 over x to the third.
You guys agree? Okay? Good stuff. The third derivative?
Negative 6
X to the fourth. And then the fourth derivative? Anybody come up with a generalization for finding the nth derivative? What happened? What about the exponent?
It's always one higher than your n.
It's always one higher than your n. So how would you?
N plus 1.
Okay, and where would that go? So could I?
D to the x to dx to the n plus 1.
Okay, you definitely round the n plus 1, but would it be d to the x down here? I'm thinking this. Remember, this is like a general formula that you use to find any derivative.
So just x.
So just x. Okay, good. All right. This would have gotten you 1 point. This this was worth 7 points. These were worth 4. So you just got 5 out of the 7. Can we get the other 2?
Well, okay, so the thing is, it's going from negative to positive to negative.
It would just be negative.
But then it's adding. It's like 2 and then 3 and then 4. I don't know how you do that.
Okay. So we got 2 things happening here. We're going back and forth between positive and negative, right?
Oh, yeah.
And then the numbers are changing. Okay. So there's 2 different things. Those are the other 2 points right there. How do you represent that?
So I can make it go negative to positive by having it be like negative 1 to the n times whatever the number would be.
Yes, if n is the the particular derivative that we're taking, right? If it was the third derivative, right? Negative 1 to the third power would be a positive or a negative. Okay.
Plus 1.
Say that.
Would it be plus 1? Because.
Well, no, n represents the particular derivative we are. So you want to keep it as n. Now, how do we get that number to change the way it's changing?
I think we learned like this is different symbol you can use for it. But I don't. It's like old.
It's old. Algebra 2. Yes.
Would it be the exclamation point?
Yes.
Factorial.
Yes. Factorial. You would have learned this back in Algebra 2. Okay? Factorial basically means that you, if you do 2 factorial, it's the same thing as 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Look at that. 2, 6, 24. So, the last bit to get the 7 out of 7 would have been n factorial. Together. You guys are amazing.